Hello, everyone, and welcome to the second day of Programmers Week from Cognizant Vision. It's my third year as a speaker, and I'm really excited to be a part of this Allison community. Before we start, I have some bad or good news, depending on your expectations. While preparing for this presentation, I decided to do the demo in .NET 5 instead of .NET Core. Why .NET 5? Because the production release is around the corner, and why not use the latest and the greatest version so far of the .NET framework, right? And on the gRPC side, at least for the coding style, the implementation is almost the same. So don't worry, you'll be able to use the same examples both in .NET Core 3.1 or .NET 5. So a little bit about me. My name is Jon Gricko. I'm working as a .NET backend developer for more than 7 years already. I joined Cognizant Vision 5 years ago. I'm really interested in latest technologies, and my current focus is on microservices and their integration with microservices with cloud computing. While checking the microservices architecture, I studied also the gRPC, and I think that it's a really cool technology and can add some big value in some of the projects. So let's check it out. Okay, so today we'll talk about what is gRPC and why it's important to understand the benefits behind this framework. What are protocol buffers and why they are important in this context? And then we'll have 2 demos because that's what we really like, coding, right? We'll create a gRPC service from scratch in .NET 5. And then we'll see an existing application that I created last year for Programmers Week, where I integrated again gRPC Web. And we'll talk a little bit later what gRPC Web means. If you have any questions, please use the Q&A section and we'll discuss them at the end. Okay, so probably you think that gRPC stands for Google Remote Procedure Call, right? Because in the end, Google created this framework and made it open source in 2015. But actually, gRPC stands for gRPC Remote Procedure Calls. This is the actual name, gRPC, of the framework. Remote procedure calls are not a new thing. They are here like for 50 years, and you probably are already using them in distributed systems. gRPC is just a new framework, a high-performance framework. It's open source and was created by Google. The initial version was created from Stubby RPC framework used initially just internally at Google. There are multiple versions or multiple frameworks out there for remote procedure calls, but gRPC seems to have the strongest community, and it's actually a project of Cloud Native Computing Foundation, meaning that in the following years, this framework will be developed, and we have at least to check what can this project add to our context. Okay, let's talk a little bit about the technologies behind gRPC because they are pretty important in this context. So we're talking here about HTTP2, first of all, and with the protobuf or protocol buffers. And we'll discuss in a minute why protocol buffers are important, because this is an important part of the gRPC framework. gRPC was designed with the scope to build modern applications with high performance. So performance and the speed is one of the most important part of gRPC framework. Since we are talking here about the HTTP2, we are talking here also about the binary communication. This is the default communication method for the gRPC. But of course, you can use also other text-based gRPC frameworks. It's platform independent, meaning that you can create a gRPC service in C#, but then you can consume it in a Java client or in a C++ on a Python client. So we don't really depend on a specific platform. And this is a really cool stuff, if you ask me. And probably one of the most important feature of this framework is that it's bidirectional. It supports bidirectional streaming. So if you are working on projects like with video streaming or stuff like that, this framework can add a really big value to you. Okay, so who is using gRPC? Some of the big companies like Square, Netflix, or Cisco already adopted this framework. And this is just a sign that this technology is here to stay, and at least you have to check it. and see if it's valuable for our projects. And if yes, why not implement it? Because we already have support for it in .NET Core 3.1, so it's production ready. As I mentioned earlier, it's important to understand protocol buffers because gRPC at its core is using protocol buffers. Protocol buffers are not something new. They were created in 2018 at Google, and it's a language neutral, platform neutral, and extensible mechanism for serialization the data. The main focus for gRPC for the protocol buffers is performance and efficiency. And we'll see in a minute how protocol buffers succeed to have a greater performance and efficiency versus other serialization mechanisms, like for the JSON or other text-based mechanism. gRPC is using a custom interface definition language version. There are multiple versions, at least 3 for now, Proto 1, 2, and 3. As you can see, the syntax for the interface definition language is pretty simple. These proto files remind me of interfaces that you have in C# or any other languages. You don't really have to understand or to learn a new language just to create these proto files. They're pretty simple to understand. You have just the signatures for the methods and just the messages, and that's it. And we'll talk a little bit later what every line from this proto file means when we'll create an example in .NET. Okay, so I talked earlier that gRPC and protobuf are focused on the performance and efficiency, and how they do that. So if you do a comparison between protobuf and JSON, for example, the main reason protobuf succeeds to have a greater performance and efficiency is because of the separation between context and the data. And what does this mean? On the JSON side, when you have to send an object, for example, in this case, just with 2 properties, first name and last name, we have to set every time also this context. I mean, the property's name, right? So if you have like 1000 objects of this type, this means that we'll send every time also the first name and the last name. And you'll see that this can add some really big value to the message side. So instead of having just the data, in this case, my name, Ion Gricko, we'll have also the first name and last name. On the protobuf side is different. The context is known by the client and by the server, in this case, the message, so they don't have to send it across the network anymore. So while sending the messages across the network, on the protobuf side, we'll send just some identifiers for the data. So in this case, if I'm sending Ion Gricko over the network, I'll send just 1, 2, 3 Ion, and that's it for the data. I don't have to send the entire property name. And this identifier means 1 is for the tag. Every property has a tag. And then 2 and 3 is the type and the length of the property. In this way, when serializing and deserializing the data, client and the servers know about the contract. Of course, the constraint is that both client and the server should know about this contract. But okay, we'll have a greater impact on the performance, so it's sorted. And just to see a little bit of difference between protobuf and JSON serialization, as you can see on the encoding side, the performance and it's twice faster than on the JSON side. But on the coding, we have like 5 times faster than on the JSON side. So this is just a sign that, okay, gRPC, it's a really cool technology, and you have to really consider it if performance is an important thing for you. So you'll ask probably, okay, does this mean the rest is dead and we should all move to gRPC? Of course not. gRPC is a really cool technology, but currently it's not really prepared for the web. And why is that? First of all, is because of the HTTP2. Not all the browsers are supporting HTTP2 yet, or at least not fully. And since we are talking here about the binary format of the messages, sometimes JavaScript is not able to parse correctly these formats. So for now, gRPC is recommended mostly for the inter-service communication and not web applications. And even if there's an initiative called for now gRPC Web, and even Microsoft released a package in June, gRPC Web, that we'll see at the end in the last demo. The idea is that, at least my advice is, don't just jump on it just because it's shiny and new. And this is available for any new technologies like GraphQL or SignAlert and so on. Every of these technologies have their own specifics, so choose wisely and choose what's best for you, but don't jump on them just because they are new. Okay, and let's move to the code because that's what we really like, right? Okay, so we'll create a new project from scratch in .NET 5, like I said in the beginning. You need for this the Visual Studio 2019. And of course, you can select .NET 5 or .NET Core 3.1. As you can see, gRPC is supported starting from .NET Core 3.0. So you'll have, at least from what I saw, the code is exactly the same. So don't worry about it. There are some improvements behind the scene on how gRPC works, but at the coding level is the same. So if you are already familiar with the .NET Core and you're already working on .NET Core projects, you'll see that the project structure is almost the same as on any other .NET Core application. We have the program CS, we have the startup CS, we have the application settings and so on. If you open the startup CS, you'll see that we have even the middleware like routing or endpoints or developer exception page and so on. So the look and feel or the user experience created by Microsoft for gRPC is the same as for any other web applications. And this is the really cool stuff, if you ask me. So let's check the dependencies because they are pretty important in this context. There are two packages that we have to consider here. First of all, it's Google Protobuf. This is the protocol buffers mechanism for serialization and deserialization. So you need to make sure that you have this package installed. And gRPC tools. What does gRPC tools? gRPC tools will convert the proto file that you'll add in the project to the code behind. Okay. And the next thing, we'll check the protos files. Like I said in the beginning, proto files are pretty easy to understand, but let's check them one by one. So there are three versions of proto files. The latest version is Proto 3, and of course, this is the recommended version to use on your projects. You can also use Proto 2 version that was released with the gRPC in 2015. And the Proto 1 version is actually not publicly available, was used just internally at Google. Then this is something specific for .NET environment. We have an option called C# namespace. And you'll see that based on this proto file, .NET will generate the code behind. And this C# namespace, gRPC service 13, in this case, will be used as a namespace for these classes. Then we have a package. Package you can imagine like using from the .NET environment. And if you have multiple proto files, you can package them, you can add them in a single package and then import your package in another proto files. Okay, so next is our service. In this case, it's a simple service called greeter. And then the RPC method. In this case, say hello. It's a simple method. This is just the name of the method that has two messages, the input message of type hello request and the return message of type hello reply. These messages are also defined here below and have just a single property. In this case, for the hello request, the property called name with the tag 1, and hello reply has the same property of type string and with the name message. This tag that you'll see here and most in any proto files, it's really important because based on this tag, client and the server know how to serialize and deserialize the data. But this tag can also be used for versioning or any other things like this. You can reserve these tags in order not to use them, or you can reserve the property name the same just to make sure that nobody will use it and so on. But we'll see later how can integrate other syntax from the proto files. Okay, and that's it on the proto files. There's nothing fancy. It's just a simple service with simple say hello. It's some kind of or hello world application for the gRPC environment. Okay, and of course, for this proto file, we have an implementation behind, right? In this case, is the greeter service. As you can see, this greeter service inherits the greeter.greeterBase class. If you check the project structure on the right, we don't have any class of this type, right? So let's check what's behind these classes. So these classes were generated automatically by the protocol buffer compiler. And as I said previously, this is why it's important to make sure that you have this gRPC tools package added, because otherwise the code will not be generated automatically for you. And also what's important, if you check the properties for these proto files, you have to make sure that at the build action, you select protobuf compiler. And if you need server or the client, depending on your context, because otherwise, again, you'll not be able to implement or inherit this greeter base class. So this is the default class that was generated for us based on the proto files. And the only thing that you have to do is just to override this say hello method. So as you have in the greet proto file, we have a method say hello. So the same method we override here, say hello with the hello request type as the input. Again, this type was also generated for us automatically. And the context, in this case, this is something specific for gRPC. And we are returning a hello reply. And that's it. We are just returning a hello and the request.name of the hello request type. So nothing fancy, we are just returning a response back to the client. And our service is ready. Let's just rebuild it to make sure that it works. May the demo of the god of demo be with us today. Okay, so rebuild is successfully. So our service part of the gRPC is done. Now I would like to add a client for this service and consume it. And I'll do it also here. I will add just a console application just to show you how gRPC works and how can you integrate it with a client, with any client, of course. So in this case, if you already are using Windows Communication Foundation or any other older services, you remember that we have a thing called add service reference. So .NET made it really easy to integrate also the gRPC services in the same style. Because in the previous versions, at least when I started to look over gRPC, you had to add manually all the dependencies, you have to add manually the gRPC, the proto files, and you have to maintain them. So it was a process, time-consuming process. At this point, in Visual Studio, at least in the latest versions, you have add service reference, you just select gRPC, and you select the file that was created in the previous project. So in this case, it's greet.proto. And Visual Studio, when we'll do this, will automatically add all the packages that we need for the integration in the gRPC service. As you can see, Google Protobuf package and gRPC tools that are needed for us. And that's it. We added the references to our project. What's really cool about .NET, at least, is that we don't really have this file greet.proto added as a physical file on our console application, but it's just a link. So this means that if I go to our initial proto file, and let's say that I want to change this tag for the name to 2. Okay, and let's close it. When I open it in the client, I have directly the same update, because again, as I said, this is just a link to our proto file. It's not an actual new file, because in the previous version, the first version of the .NET, we had to add the same files, and manually every time when we update the proto file on the server side, we had to do this on the client side. Okay, so we added the reference. Now we have just to call our service. I'll just copy paste the code to not waste too much time on this. Okay, and let's add all the references needed for this. Okay, and just make this task sync. Sync task. Okay. So in order to be able to call a gRPC service, there are two main things. We have, first of all, to create a gRPC channel. So in this case, our channel, we have to specify the URL, and then we have to create the client for our protofile. Every protofile or every gRPC service will have its own client. So we cannot really use one client for multiple protofiles. For every file, you'll have a separate client. As you can see, the name of the client, of course, is greeter because that's the name of our protofile and of our service. And then we have our method, say hello async. What's really cool about gRPC is that we have both sync and async methods already in place. As you can see here in the greeter service, we didn't specify that it's say hello async or sync. So gRPC does this automatically for us. And we have just this parameter hello request that is sent as an input. And let's run it. Let's run both of the projects. So we'll do this by selecting multiple startup projects. Okay. Okay, so both server and the client are running now. On the right side here, you can see the gRPC server. So as I said in the beginning, the user experience for the gRPC service is almost the same as on web apps. So we opened the server and we have all the logs the same as we do with .NET Run on any web application. And also we have our request here. So this is our request. It's say hello. And we have also the response that finished, request that finished in 100 milliseconds. On the left side, we have our client. So in this case, we sent greeter client, and the server responded to hello greeter client. So we sent here hello greeter client, and on the server side, we have just as a response, hello greeter client, and that's it. It just works. Okay, now let's do something a little bit more complicated. Let's say that we want to add a new RPC method, right? So let's call it get programmer seek talks. And we have a get programmer seek talks request that returns. And in this case, let's not return just one single object, but let's return a string of get programmer seek talks response. Okay. What you need to know about these protofiles is that you don't have real-time compilations. So in case you add some errors here, or you have some errors here, you'll see them just when building the project. Okay, so now let's add the message. In this case, get programmer seek request. Let's suppose that we want to add all the requests for a specific day. And we'll add tag 1 for this request. And we'll create a message for get programmer seek response. And here we'll add just the talk name. The same with the tag 1. Smaller values are better for the tag because remember in the beginning, tags are also sent across the network. So if you use bigger numbers, you'll have bigger messages. So you have to really consider this. Okay, let's build the service. Okay, so as I said, since we don't have real-time compilation errors for these protofiles, now we did a mistake here. So we have to update the protofiles. Just one more thing before rebuilding. If you are trying right now to do an override, we'll see that we already have these programmer seek talks, because even if we had an error behind because of this compilation error, gRPC does or gRPC tools generates the code behind automatically for us. So now the only thing that you have to do is to override our method get programmer seek talk in this case. Okay, and we have to put our own implementation. So I'll just simulate here that let's suppose that we have 10 talks, and let's suppose also that we are doing some heavy loading on this for every of the talks. We are doing some processing, and we are simulating a delay of 1 second for every of the talks. Okay. And then on the response stream, we'll just write the response. In this case, we want to do a new get program SIG response with the name, the talk. Let's call it gRPC and I, just to see that they are different. And of course, since this is a sync method, we have to await it. Okay, so that's it. The difference between this method where we have just a single request and a single reply is that on this side, we have on the reply side, a task, just returning a task, and then all the responses back to the client will be sent via this server stream writer. Okay, let's build the service to make sure that we don't have any errors. Okay, successfully. Then we can go on the client side and just implement this, to consume this new method. I'll just copy paste the implementation to not waste time. Okay, so let's comment this because we have to rebuild the console application that even if we added this link to the proto files, remember that here at the proto file, we have for properties server only. So when we added also the proto files on the console application, on the client side, we have here the client, right? So the code behind will be generated just when rebuilding the project. Okay, let's try one more time. Okay, so now we have our code ready. We just have to use gRPC core. So what we'll do here is we'll have the same, our method get programmer SIG talks on the request for day 2. And the difference between the previous implementation is that here we have to move across all the responses and we'll display them to the client. Okay, let's run one more time in this project. Again, we'll see in the right the server. We will see both requests, say hello, and get programmer SIG talks. And on the left, as you can see, we have multiple responses back from the server. So we did a single request to the client, get programmer SIG talks, but we received multiple responses in different times. So this is a really cool stuff about streaming, and actually can do also bidirectional streaming. So both from the server to the client and to the client, from the client to the server. Okay. Now let's check the application and the second demo. If you remember last year, if you attended the Programmer SIG presentation, we talked about the mediator and how can you integrate mediator with CQRS in our projects. What I tried to do this year was to do the same implementation as I did last year in REST, but with gRPC. Let's just check this application, how it works, what it does. Okay, it's on localhost. Okay, so it's a simple web application. I just created this client in Blazor just to show you how can you use this gRPC and the service implementation, but ignore the visuals and the UX side. So it's a simple list with to-do list. You can start to-do list. You can make it as completed, or you can delete it, or even add new one. And the same implementation is on the gRPC side. Nothing different, the same data behind, the same business logic behind. So in order to do this, I had to create a new project, of course, for the gRPC side. First thing that I did was to add manually all the, or at least all the packages that I need, like gRPC ASP.NET Core and gRPC ASP.NET Core Web. As I said in the beginning, gRPC Web, at least for Microsoft, it's really new. They released the production ready, at least, version in June. So the implementation is a little bit different than on previous example that we saw. If we check the startup, so we'll have, again, add gRPC service. But when you are using, or when you are adding the middleware, you have to use gRPC Web instead of gRPC, as you did in the beginning. And the second difference is that when you map all the gRPC services, you have to enable gRPC web. Otherwise, you'll not be able to call them from Blazor or any other web applications. This setup is specific for Blazor and for Microsoft Tech Stack. So the next thing that I had to do was to add, of course, our implementation for the services. But before moving to that, I wanted to show you that if you are checking the startup classes for the REST implementation and for the gRPC implementation, they are almost the same. We have core support, we have DB context, mediator, identity, and so on. So again, the same middleware that I have on the REST side is also on the gRPC side. We also have authentication, authorization, and so on. So on the service side, we'll talk a little bit now about it, but I can add also the authorized tag, and the authorization will just work. I'm using for this project JSON Web Tokens, and I didn't have to do anything out of the box for the gRPC. It's almost the same implementation as for the rest. Okay, and first thing that I had to do, of course, was to create this protofile. It's a little bit more complex than the previous one when we had just a hello world example. So in this case, I imported also some existing types. What you can do with the protofiles, you can create these messages and add them in the separate files. Imagine that you have a real project, probably the protofile will be huge, so you don't really have to maintain them in one single file because it will be a mess. So as we have here, these are some imports from the Google. These are types created by Google, but you can do this also with your own files. You can import them in your protofiles. So in this case, I imported two types. One is for the timestamp, because by default, protofiles don't support timestamp. So I used it here, this type. And then the second one is just an empty type. In the gRPC world, you cannot return void or return nothing. So we all the time we have to return something. And in this case, we are just returning this type of empty. Of course, we can create this type by our own, but since there is an existing one, there is no need. So we have here get to-do list, add to-do list, update and delete. These CRUD operations are simple CRUD operations. Add, update, delete don't return nothing. And on get to-do list, we are returning the get to-do list reply. On the get to-do list reply, the interesting thing is that we can have also message in message, meaning that we have here nested message. Of course, we can check or get this message and add it separately and to be independent. But since this message is used just in this context for the get to-do list reply, there's no need to do this. What's again different in this case is that we have this repeated. Repeated is like a list of items. Imagine like something like stream, but on the stream side, we are returning back to the client one by one the items, but in this case, we'll return just a list of items in the same time. Okay, and on all other properties, there's nothing different. We have just some simple properties like description, username, and so on. The next step was to build a service, of course. If you're checking the to-do controller, because my scope was to create the same implementation on both REST and gRPC, and to not modify at all the business logic. So if you are checking the controller, we used here mediator, and we just created the commands and queries and send them to mediator. Nothing new, and no business logic almost at all. So I wanted to keep the same business logic or the same logic also on the gRPC side. So no business logic. The only thing that I had to do here in the to-do service was just to create the queries and the commands and send them to mediator. What I can't do is to use directly our queries and our commands directly in the protofiles, because they are generated automatically for us from the protofiles. So I had just to map the command and queries to the types that were generated from the protofiles. So in this case, I just send that get to-do list query, and then I mapped the response back to our type, that in this case is get to-do list replies.types.todo view. And for the rest of the commands, they are almost the same. Nothing different, just creating the commands and queries and send them to mediator. Okay, and since the middleware, as I said, was almost the same on both gRPC and the REST side, I just created a common server or common project where I added all the service extensions for adding the mediator, identity, and all other common stuff. The next step was to add a Razor page also for the gRPC. If you're checking the REST page, it's pretty simple. We have just a HTTP client injected in our page, and then we have our basic commands. Like you can see in the interface, you have just complete or CRUD operations over this list of to-do items. Okay, and that's it. What is different here that we had to add an authentication state just to get the token and send it also on the request. And that's it on the REST side. So on the gRPC side, there are two differences. First of all, we cannot use HTTP client anymore because gRPC it's working with gRPC channels, not with the HTTP client. So instead of injecting the HTTP client, we had to inject the gRPC channel. In order to be able to do this, we had to go to the program CS and add the singleton service of gRPC channel. Of course, for our address, in this case, localhost 5003. And based on that, gRPC channel will be injected in our page. And we have to specify that this is the gRPC web handler or web channel. Okay, and next, as I said, on the gRPC side, we don't have headers. So we don't have authorization by default. So my question was, okay, if we don't have headers, how authorization will work? Since for at least for what I knew, is that authorization will be able to work just by headers. And this authorized tag knows just the headers, not the metadata that is using on gRPC. But the surprise was that this implementation is built in already in .NET Framework, at least in .NET 5. So I had just to add this authorized tag and the authorization just works. What I did on the gRPC side was to get, of course, the token from the local storage service and then add metadata and add the authorization and the bearer token. When we're calling our methods from the gRPC client, besides the request or the input request that we have to send to the server, we're sending also the headers. And in this case, is this metadata. So in this way, .NET Framework knows, okay, if it's the gRPC channel, I have to read the data from the metadata. If it's the REST client, I have to read the data from headers. So it's built in somehow. Okay, and that's it. It's nothing fancy. We have just this implementation with, and instead of using HTTP client and endpoints, we're using here gRPC client and a gRPC channel. Okay, so let's check a little bit the network on this side because this is the interesting part of the gRPC at least. Let's add some more items on the list that just to have a little bigger the message. Okay, so let's check the REST implementation. For the REST implementation, we have a classic call to the endpoint, in this case, API to do. And as you can see, the size of the message is 1.2 kilobytes. Let's check what happens on the gRPC side. So on the gRPC side, we have get to do list because that's our method that we called. But the really cool thing is that the message is almost more than 2 times smaller than on the REST side. And this is because of this separation of the data that I talked in the beginning between the context and the data. So on the to-do list, we're sending all the time, okay, all the properties name and the data, properties name and the data, and so on. We cannot see the output of the gRPC because it's in binary format, and of course, it's not visible in the browser. But if we were able to see the data that is sent across the network on the gRPC side, we'll see that we'll have just some identifiers and the data. And because of this, we have a message a lot smaller on the gRPC side. So if you ask me, this is one of the main reasons I would choose gRPC over other types of the technologies when we are talking at least from the low streaming projects, or when this is or the size of the message is really important. Okay, so we did both demos, and that was it. So for the references, if you are interested more in learning about gRPC, the official documentation from grpc.io, it's really helpful. You can find there a lot of resources, but also on the Microsoft side, you can check the gRPC implementation for the web or the simple gRPC. And what's really important to understand how they work and how can you implement it on your project is to learn about protocol buffers. Of course, these protocol buffers, you can find any information on the developers from Google site, and there you'll have a lot of information. And if you are interested in this project with the integration for gRPC, you can check it on my GitHub account on Clean Architecture project. Okay, and that was it. If you have any questions, we'll check the Q&A section. But if you want to ask me anything later, you can send me anytime an email to yon.gritscore@solvision.com, and I'll reply as soon as possible. Okay, let's check the questions. Can I host a gRPC service in an Azure App Quiz service? From Robert, at least from what I know, for now, you cannot host a gRPC service. There are some issues with IIS at least and HTTP2. So from what I know, you can't do this for now. Okay, and that's it. Thank you then. Okay, thank you for your time. And again, if you have any other questions, please send me an email or